Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 2, Multiplying and Factoring Polynomial Expressions. Okay, it starts off with a classwork example 1, using a table as an aid. Use a table to assist in multiplying x plus 7 times x plus 3. Okay, so they did it already for you. X times x is x squared, x times 7 is 7x, 3 times x is 3x, and 3 times 7 is 21. This is darkened here because they're pointing out that these are like terms, so when I finally write my final term, I start with the x squared term, combining my x's, which is 3x plus 7x, which is 10x, and then plus 21. So that is using a table as an aid to create your polynomial. So exercise 1 says to use a table to aid in finding the product of 2x plus 1 and x plus 4. So what I hadn't said was x plus 7 is across the top here, x plus 3 is down the side. So they put the first term across the top and the second term down the side, so we'll do the same here. This is an exercise, so pause the video, see if you did it properly, and then when you come back, we'll check it. Okay, so 2x plus 1, so I'm going to write 2x here, plus 1 over here, and then x plus 4 down the side. X times 2x is 2x squared. X times a positive 1 is a positive x. 4 times 2x is 8x. And 4 times 1 is 4. And so now we have, let me change colors here. This term and this term are like terms. So my answer is going to be my squared term first. My combined same terms, 8x plus x is 9x. 8x plus 1x is 9x. And then my constant by itself. So the answer is 2x squared plus 9x plus 4. Polynomial expression. A polynomial expression is either 1, a numerical expression or a variable symbol, or 2, the result of placing two previously generated polynomial expressions into the blanks of the addition operation, something plus something, or the multiplication operation of the first term times the second term. Okay. Exercise 2 through 6 says multiply the following binomials. Note that every binomial given in the problems below is a polynomial in one variable, x with a degree of 1. Write the answers in standard form, which is right here, where a, b, and c are constants. And actually a and b are coefficients. Okay, so x plus 1 times x minus 7. These are exercises, so pause the video, see if you can do it, and then we'll see how you did. All right, so here it goes. X times x, x squared. Outer, x times negative 7. Inner, 1 times x. And then last, 1 times negative 7, negative 7. Combine my like terms, and I get x squared, negative 7x plus 1x is negative 6x minus 7. Okay, number 2. Well, that was number 2. Number 3. It was the first one, but they numbered it 2. All right, so x times x, x squared. X times 2, 2x, plus 9 times x, 9x, and then finally the last terms, 9 times 2, 18. Combine the middle terms, and we end up with x squared plus 11x plus 18. X times x, x squared. X times a negative 3, negative 3x, careful with your signs. Inner is negative 5 times x, which is negative 5x, and be careful, a negative times a negative is positive. 5 times 3 15, combine like terms. X squared minus 8x plus 15. Okay. First term is x. X times x is x squared. Outer, x times negative 1 is a negative x. Inner, 15 halves times x is 15 halves x. And then last, 15 halves times negative 1 is negative 15 over 2. Okay. Here we have a fraction. So keep in mind that when we have fractions, the only way we can add them is if we have the same denominator. So I put a 2 here, and this is a 1, so we all know that 2 over 2 is 1, so pretend that's right in here. All right, now we're going to continue. X squared is my first term. I'm going to combine these, which is a negative 2 halves plus 15 halves, so 15 minus 2 is 13 halves. X minus 15 halves. So be careful with that, and remember that a whole number can be represented as a fraction. Okay, number 6. X times x. All right, thought I changed the color. X times x. X times a negative 3/4 is negative 3/4 x. Negative, and then inner, negative times a positive is negative 5 over 4 x. And then last, negative times a negative is positive. And we're multiplying 5/4 times 3/4. 5 times 3 is 15. 4 times 4 is 16. Okay, combine like terms, and we end up with x squared. Negative 3/4 minus 5/4 is a negative 8/4. Negative 8/4 x plus 15/16. Now this negative 8 over 4 simplifies, so that's going to equal x squared minus 8 divided by 4, which is 2x plus 15/16. So it's x squared minus 2x plus 15/16. Okay, so it says to describe any pattern you noticed as you worked. Okay, well, if I look up here, we had an x squared in the first term every single time, and therefore our leading coefficient is always 1, or in this case, our a is always 1. Okay, and so there's a lot of writing here, so I'm just going to paste it. Okay, so here it is. All of the coefficients for x squared term are 1. The constant term for the resulting trinomial is the product of constant terms of the two binomials. In other words, this last term is just this times this multiplied. This term times this term multiplied. Negative 5 times negative 3 is positive 15. Okay. There are always two terms that are like terms and can be combined. So we've always added those two middle terms, as you can see. The coefficients of those terms after they are combined is the sum of the constant terms from the two binomials. Okay, so if you notice, negative 5 minus 3 is negative 8. 9 plus 2 is 11. 9 and 2 is 11. Did that already. 1 and negative 7 is negative 6. So there's a shortcut. If I see this now, I'll just write x squared. 1 minus 7 is negative 6, and then write the x after it, and then the product of 1 and negative 7 is negative 7. So it's kind of a shortcut to do that. Okay. Factor the following quadratic expression. So now try that knowing that shortcut, and then we'll come back. Okay, so here goes. Now this says to factor this quadratic. We're going the other way now. So now we're going to factor. So I'm going to have two parentheses. X squared is x times x. And then we're going to take the factors of 7 So here's what I tell my students. So we have ax squared plus bx plus c. So what I tell them is factors of c that add up to b. So I'm looking for factors of 7. Well, 7 is 7 times 1. And then we add them. 7 plus 1 equals 8. Well, there's my 8. So I know my factors are 7 and 1. And since everything's positive, it's plus, plus. Factors of C that add up to B. Okay. So I also tell my students list what A is, what B is, and what C is every time. And then take factors of that add up to that. The sum of the factors that equals your middle term. Okay, it seems like a lot, but after you do it a few times, it makes it quite simple. So here, this is how I do it on number 8. My A is 1m squared, so my A is 1. My B is 1m, or my B is 1. The number in front of, the coefficient in front of m is 1. And my constant is negative 90. So I want factors of negative 90 that add up to 1. So my factors of negative 90 are, let's just do factors of 90 and we'll worry about the negative after. 1 and 90. 2 and 45. 3 times 20. 4 times 2 is 8, 10, 4 won't go. 5 and 18. 6 times 15. 7 will not go. 8 will not go. 9 times 10. And when we get this close where they're one apart, they're just going to repeat. So I'm just going to repeat them now. Okay. 1, 2, 3, 5, 6, 9, and 90, 45, 20, 18, 15, and 10. So 1 times 9 is 90, 2 times 45 is 90, and so on. This one I'm going to make all negative. And this one I'll make these all negative. So those are all the factors of negative 90. I want them to add up to B, which is 1. So that's a product of 89. This is 43. This is 18. 17, I mean. This is 13. And so what we're looking for are differences of 1. There's 1 there, and there's 1 there. And then we have to find the sign. So none of these will work. So it's negative 9 times 10 is positive 1, so that's the one we use. So then we just write the variable. And minus 9 plus 10. Okay, and that's how we do these larger ones. Okay, so again, what is A? What is B? And what is C? I want factors of 40, which are 1 times 40, 2 times 20. And I look at the differences of these as I go. Well, 40 plus 1 is 41, 22. I want 13, and this is negative. Okay, so then I know that it's 2 negatives, because a negative times a negative is positive, and this is a product. So these are all going to be negatives. And you're going to learn that after a while. It just gets to be common, just nature to do that quickly. Okay, so 2 times 20 is 40. 3 won't go. Negative 4 times negative 10 is 40. And that's negative 14. Okay, and we keep going. Okay, negative 5 times negative 8. 5 times 8 is 40. Negative times negative is positive. And there is our 13 if we add them. So my answer is going to be K minus 5, K minus 8. Factors of C that add up to b. Here are factors of c, and when you add them, they equal b. Okay, one more time. Remember, factors of c that add up to b. So I need to know what a is, and in this case it's 1. B is 99, and c is negative 100. So I want factors of negative 100. Well, to get factors of negative 100, it's a positive times a positive times a negative. 3 won't go. Positive times a negative. Oops. Five, negative 20. 6 won't go, 7 won't go, 8 won't go, 9 won't go. 10 times 10 is 100. Okay. Oops, that's 100. Okay, well, positive 1 time plus a negative 100 is negative 99. So all of these won't work. So what we're looking for is 1 and 100 to get a number 99, but it's going to be the opposite. So then these can all be negative. Negative 1, negative 2, negative 4, negative 5, negative 10. So 1 times negative 1 times a positive 100, negative 2 times 50, negative 4 times 25, and negative 5 times 20, and negative 10 times positive 10 all give you 100. Here are our two factors of c. This is c, factors of c that add up to b. 100 plus a negative 1 is 99. So my answer is v minus 1 times v plus 100. Okay? Example 3. Quadratic expressions. If the leading coefficient for a quadratic expression is not 1, the first step in factoring should be to see if all the terms in expanded form have a common factor. Then, after factoring out the greatest common factor, or GCF, it may be possible to factor again. For example, to factor 2x cubed minus 50x completely, begin by finding the GCF. Since the a, or the leading term, is not 1, you try to find a factor that will take away this 2, and the other factor is, or the other term has a 50, so we can factor out a 2. The GCF of this expression is 2x. Since there's a 2 here and 2 will go into 50, there's 3 x's here and 1 x here, we can take one of the x's out. And when we take out 2x, we're left with x squared minus 25. Now factor the difference of squares. Since that's a minus sign, perfect square, we get 2x times x minus 5 times x plus 5. And that is the factored form of 2x cubed minus 50x. Another example, follow the steps to factor negative 16x squared plus 32t plus 48 completely. So it says A, first factor out the GCF. Remember, when you factor out a negative number, all the signs on the resulting factor change. So I know 16 will go into 32 and 16 will go into 48, so I can factor out the negative 16. There's a t squared, there's a t, but there's no t here, so this is all I can factor out. The greatest common factor is a negative 16. And when I factor that out, a negative times a negative is positive. So I want a negative times a positive is negative, my apologies, so this should be positive t squared here. So negative 16 times t squared is negative 16t squared. And then we have plus 32t. Well, we factored out the 16, so it's like dividing. So take 32t divided by negative 16, and a positive divided by a negative is negative. 32 divided by 16 is 2, and the t is still there. Okay. And then we have 48 divided by 16. Positive divided by a negative is negative. 48 divided by 16 is 3. And that is our answer. Okay, so negative 16 times t squared minus 2t minus 3. Okay. Okay. So So whenever you factor, whenever the first term is negative, we don't want the negative inside the parentheses here. We want to factor out that negative. So always take the negative out and then change all the signs inside. We want a positive t squared in that first term. B says now look for ways to factor further. Notice the quadratic expression factors. So now we have the negative 16 is still there, and we're going to factor this further. Okay. In other words, we have a t squared, we have a t, so I know that's going to be t times t to give me my first term, t squared. The middle term is negative, so I know that one is negative and one is positive. Okay, and now we're just, and then remember what I said, factors of c. So in this case, a equals 1, right here, b equals negative 2, and c equals negative 3. So I want factors of negative 3 that add up to negative 2. So it's 1 times 3 or 3 times 1, and this is how we do it. So negative times a positive is negative, and negative times a positive is negative. And which one will give me the negative 2? Well, it's this. Negative 3 plus 1 equals negative 2. So it's minus 3 plus 1. So my final answer is right here. Okay, that is the end of lesson 2. Review the lesson summary and go do your problem set.